Hi guys, welcome to our last new video about factoring. Today we're going to discuss how to figure out what type of factoring you should do and how to make sure that you're factoring completely. For today's video, you're going to need your factoring book and your math notebook. So if you need to go grab those, pause the video and go grab those right now. For your factoring book, we've already filled out the entire inside. So what we're going to do next is we're going to write on the back of the factoring book. So go ahead and turn your factoring book over to the back, and we're going to create a flow chart of how to figure out what type of factoring you should do on a problem. So in general, when you're factoring, the first thing you should check for on every problem, doesn't matter what it looks like, always, it's a really quick check, right? And sometimes it's there and sometimes it's not, but it's really helpful if you do check. And that is, you should check for a GCF, okay? So go ahead and write that again at the top up here. We're gonna make a nice flow chart. The first thing you check for when you're factoring is check to see if there's a GCF. If there is a GCF, factor it out to the front, write it in front of some parentheses, and then don't forget to put your GCF as part of your answer as well. If there's not a GCF, that's fine. Then we move on to the next thing. If there is a GCF, you do still need to check and see if you can factor more. So just because there's a GCF, that doesn't mean that that's the only way you should factor. Once you've decided if there is or isn't a GCF and you've dealt with that, the next thing you're going to do is you're going to decide how big is this problem? Is it a binomial, trinomial? Does it have 4 terms? What's the size of it? And depending on the size of the problem, we're going to do different methods. We even wrote it down on the side of your factoring book. So if you decide that something is a binomial, the next thing you should check for is to see if it's a difference of squares. A difference of squares, remember, is 2 perfect squares with a subtraction sign in the middle. If it's a difference of squares, then you should factor it. If you have a binomial and it is not a difference of squares, then there's nothing else you can really do with it. If you decide that it's a trinomial with 3 terms, there are 2 different methods that we can use on a trinomial. Now, the first method you can check for is perfect square trinomial. That method is not used very often, but it is a really quick check. Are the first and last numbers perfect squares? Is the last number a positive? A lot of times you're going to say, no, that's not true. And then you would just move on and you would do X box. But if you say, yes, that is true, then you should try for perfect square trinomial. So remember, perfect square is a special case. It happens sometimes. And if you can figure out when it's happening, you can get to your answer a lot quicker than X box. That being said, Xbox can be used or tried for on any trinomial. Even perfect square trinomials will work with Xbox. What will happen is you'll just get the same number on both sides of your X. If it's not a perfect square trinomial, again, you should still try Xbox. If Xbox does not work, then there's nothing else you can do. If you decide that your polynomial has 4 terms, then you can do just the box method. Now, if you've done all the flowchart, you checked for a GCF, there's no GCF. You checked if it's a binomial, if it's a difference of squares, it doesn't work. Trinomial, Xbox doesn't work. 4 terms box doesn't work. Like you've tried everything you can think of and nothing works, then we say that that problem is prime. So prime means that no factoring works. It's not factorable. Now, if you do even just one type of factoring, then it is not prime. So let's say that you do the GCF and then you try Xbox and Xbox doesn't work. That doesn't make it prime. You've already done some sort of factoring. You already did the GCF. So as soon as you do one type of factoring, it can no longer be prime. So prime is just like, I literally can do nothing with this problem. All right, so we're done with your factoring book. We're actually have now completed all of it. So you have every type of factoring and we have our flow chart to help us out. So what I'd like to do next, I'm going to give you 10 problems and we're going to try to figure out like what type of factoring do I need to do? What is the final answer after I do factor? Like what's up with these? So I've listed our 5 types of factoring across the top. I listed them in the order that we learned them, right? So first we did GCF, then box, X box, perfect square trinomial, and difference of squares. And so in your math notebook or on a piece of lined paper, go ahead and write down these 10 problems and see what you can do with them. See if you can figure out like what type of factoring should I do? When you're ready to check, go ahead and unpause the video and we'll check together. All right, let's see how you did. So on number one for sure has a GCF because all these numbers are even. So definitely has a GCF. And then since this is a trinomial, we should also try X box. Now on number one, GCF and X box both work. So you were able to do 2 types of factoring. And we end up with this for our final answer. So 8 was my GCF. And then after I did X box, I got 2x plus 1 and x minus 3. On number 2, there's no GCF. 81 and 16 do not have any common factors, and x and y are different letters. This is a binomial, so we should have tried for difference of squares. Now this one is special. This one has difference of squares twice. And we did go over an example of this in Friday's video as well. So after you do the difference of squares the first time, in our parentheses, we do have another difference of squares, so we would need to factor it a second time. Remember, anytime you have to factor something twice, you end up with 3 parts to your answer. In number 1, I factored twice and I had a GCF and 2 parentheses. In number 2, I factored twice and I ended up with 3 parentheses. If you're only factoring once, you should end up with 2 things in your answer. For instance, on number 3 has no GCF. It is not a perfect square trinomial because my last number is negative. To be a perfect square trinomial, it has to be a positive. So on number 3, I should try X box. On number 3, I only factored once, so I got 2 things in my answer. All right, number 4 has a GCF. 24 and 8 are both divisible by 8. And then it might be a difference of squares, and it might not. So let's check. Nope, just a GCF. So after I took out my GCF, I got 3x squared minus 1. That is not a difference of squares because I do not know the square root of 3. So just the GCF. Now again, that doesn't mean it's prime. I did do some factoring. I factored out a GCF. Number 5 also has a GCF. Each of these has a letter X. It might also be X box. I don't know. I'd have to try it. Looks like it's just a GCF. So for this one, for the X to work, right, we have 2 times 5 is 10, so 2 numbers that multiply to positive 10 and that add to negative 3. And it won't work if it's a positive 10. All right, for number 6, I have 4 terms, so I'm going to go straight to the box method. And this is what I got after the box method. Same thing with number 7. Number 7 also has 4 terms, so we should try box method. Now, number 7 is a little bit tricky, so we have this second parentheses. It's t squared plus 1. That can almost be a difference of squares. So after you factor, if you still have an exponent on your variable in your parentheses, you should keep trying to factor. Anytime that there's an exponent on your variable, it's possible that it could factor again. So you want to just keep double checking until you're confident that you can't factor anymore. All right, number 8 definitely has a GCF. It's 4a, and then it might also be X box. Oh, it was actually a perfect square trinomial. So after I took out my GCF, I got a perfect square trinomial. Now, if you didn't recognize that it was a perfect square trinomial, that's okay. X box also works. You're just going to get the same thing twice. You're going to get an a plus 1 times another a plus 1. All right, number 9 has a GCF, and maybe it's a difference of squares. I won't really know till after I take out my GCF. And it looks like it was. So GCF and difference of squares. Again, notice that on all these ones where I listed 2 types of factoring, I ended up with 3 parts to my answer. All right, let's take a look at that final one. So this one is a trinomial. I can try for perfect square trinomial because look, the first number is a perfect square, the last number is positive and also a perfect square. So maybe this is a perfect square trinomial. And it is. So the final answer for number 10 is 1 minus 4u squared. All right, guys, this was our final new video. We reviewed all the different types of factoring and how to figure out what type to use and when to stop. All the rest of our homework is just going to be practicing factoring. I'll see you later.